are not the same. They're not identical. All right? Think about sperm. Sperm's function is to deliver dad's DNA. Right? I have 4 kids. Are all 4 of my kids identical? Hell no. Not no. That's a big hell no. My daughter is 6 foot tall, thin as a rail, sense of humor like mine, but looks exactly, thank God, like my wife. Right? Then you have my 17-year-old son, Jack, who's 6'4", right? I'm as tall as Pagano's have ever gotten. Right? This is the best Pagano's ever got height-wise, until Jack came along, right? And Luke and Ben are going to follow suit, I'm sure, right? He could give 2 rats rear ends about music and stuff like that, but sports, give him a ball, and he's golden, right? My daughter is very extroverted. My son is very introverted, right? Then you have Luke, right? My 13-year-old Luke, who looks just like my wife's side of the family, but he's got my build. He's going to be broad-shouldered. He's going to probably be like 6'6", 6'7", 270 when he's done. He's going to be a big dude. I told your wife. My wife is better part of 6 foot. Yeah. Then you have Benny, right? Then you have Benny, my 9-year-old, right? Again, produced by the same 2 people. Benny, right, looks exactly like me. I mean, if you took a picture of me at 9 and put it next to my son Ben, the only thing that tells you that one is him and one is me is the age of the picture and the difference in clothing. Because let's face it, back in the 1980s, we weren't wearing the same clothing we're wearing today, right? Which is when I was 9. All right? So 4 kids produced by the exact same 2 people, although Luke, I think, could be the milk names, but, right? My wife doesn't like that joke either. But everyone else tends to think it's funny. Anyhow, produced by the same 2 people, but are not in any way, shape, form, or fashion alike. Very, very different, 4 very different human beings. Forget about the fact that one's a girl and 3 of them are boys. That's potato, potato. But personality-wise, trait-wise, they picked up different traits from me. I can see traits in each of my 4 children that I definitely attribute to my half of the equation. And then I can see traits in each of my 4 children that I can definitely see from my wife's side of the family. All right? My wife, at almost 6 foot, is the shortest person of her family.
Jeez.
Her mom, her father, her brother, and sister are all 6'1" and up. Right? Father's 6'3", brother's like 6'5", sister's 6'1".
Jesus
Right? My wife, at almost 6 foot, is the runt of her family. Right? You go to a family reunion at my wife's side of the family, and it's like this the whole time. What the hell happened here? Right? You go to my family reunion, we're all doing this. My sister's 5'2" on a good day. On a good day, my sister's 5'2". Right? So the fact that my kids have all this height, that's Heather's side of the family. Right? Broad shoulders, right? My wife's family could all fit in a circle this big. Right? Paganos can't even come close. I can't even put my thigh into this. Right? We're just thicker. We're just thicker people. Right? It is what it is. But the reason why that is the sex cells that my wife and I produce, which carry half of my kids' chromosomes from me and half of the kids' chromosomes from her, they're different. So they picked up different traits. And so in meiosis, what we're not producing is identical cells. Yes, they're all sperm cells. Yes, they're all egg cells. But the genetic material that these cells carry is going to be different. That's why each of you are probably different than the siblings that you call brother and sister as well, right? Everybody kosher with the differences. And that's the key thing, know the difference.
Does
So,
that still apply to twins? Does that still apply to like twins?
twins are different animals. So twins come in 2 varieties. Right? You have identical twins and you have fraternal twins. Identical twins, one egg that was fertilized splits into 2. They're going to be identical. Right? If you've ever met twins where you can't tell the difference between the 2, my son Benny, he has these 2 young boys. They're really nice boys. One's name is Marco, one is named Diego. Right? And they're great kids. I physically have no idea which one's which. So when I refer to them, I just refer to them as Marco Diego. Like, hey, Marco Diego. And they both come running. And then I get the one that I want, like, hey, what's going on? Your shoes untied. Right? Say hello. And they answer to it because they're like, that's what their teachers do. their mother has a hard time keep telling them apart. Right? So she dresses them in a way every morning, because you know how a lot of people, they have twins, they dress them identically? She's like, heck no. She's like, Marco's always gonna do this, and Diego's gonna do that, and that's how she can tell them apart, by how she dresses them, right? On the other hand, you run into fraternal twins, like my sister-in-law has twins, right, 2 twin girls. They look nothing alike. Like this one girl's like this big rough and tumble girl, and the other one is this stereotypical little girl, loves dresses and doesn't like to get dirty, and then the other one like loves to play baseball and beat up her brother, and I'm like, what the hell happened here? This is awesome, right? But you have to treat them differently too, because like if you try to play like T with the one, she's like, get the heck out of here. But the other one, you can't do anything rough and tumble with, she gets all, backs off. So those are fraternal twins. What happened there is 2 eggs produced by my sister-in-law happened to get fertilized at the same time, right? So she had 2 separate pregnancies, but with it, 2 different sperm, which delivered 2 different DNAs from dad, 2 different eggs with 2 different DNAs from mom. Where in the Marco Diego scenario, the 23 chromosomes from mom and the 23 chromosomes from dad met, and then that split. Does that make sense? That's what's the difference between fraternal and identical. So, in the mitosis, to go through mitosis, we're going to kind of breeze through this again so that we can go through it one more time. Again, when we think about the cell cycle is separated into 2 different phases. We have interphase, and then we have the phases of mitosis. In interphase, a cell is undergoing its normal everyday processes. And as you look at the models, the model with the number 1 on it, this is showing a cell in interphase. You should also know that this one is interphase because its base is a little bit different in shape than all the other ones. If they put this one out there and you miss interphase, you have nobody to blame but yourself. They will cover the number, but they can't cover the shape, right? This one's got a big base. All the other ones have little bases. And they pick interphase frequently enough. They did last semester. So don't miss interphase. In interphase, what we're seeing is a nucleus, just like we normally would, and these little black dots represent what organelle? It's the centrioles. So we see the 2 centrioles right next to one another, just like they would be in a cell that is not divided. Everybody kosher with interphase. And I'm going to put them over here. We'll put labels on them so you can take pictures. Now, under the microscope, when you look under the microscope at these phases, what you are going to see is a cell that looks something like so. You can see the perimeter of the cell, or the plasma membrane of that cell. And when you look in the nucleus is going to be a pink or a purple color. It will be a lighter tone than every other cell that we're going to look at here this morning. This is one that's hard to miss, as opposed to the nucleus over here, which is what color? It's black. It's a black color, right? This is a cell that's under mitosis. This is a cell that is not under mitosis. And the difference between the colors is the purple is purple because the chromosomes are relaxed. The chromosomes, when they condense, turn black. So they become thicker and more condensed. As a result, they stain darker. As a cell starts the process of division, or starts the process of mitosis, the first phase it's going to go through is something called prophase. And we talked about in lecture today 3 key events that occur during prophase. Now, your book subdivides prophase into early and late prophase, which, don't get me wrong, I'm fine with that. On the test, just put prophase, right? You don't have to impress me with early and late. Just tell me that it's prophase. When you look at model number 2, so as you look at this model on the base, it's got the number 2 for you. What we are looking at is the first 2 things that occur during prophase. Thing number 1, and we can kind of see it in the left-hand picture where it says early. The first thing we see is the centrioles start to migrate to opposite sides of the cell, which is what's occurring here. The second thing that we see is the chromatin, that relaxed genetic material in the center of the nucleus, starts to condense. And what we can see in the nucleus is the condensing of the chromatin into chromosomes. Everybody kosher with that?
And this is when it starts turning black.
One more time?
And this is when it starts.
Well, yeah, if you look at the pictures up top, see how the nucleus now is black? It's definitely a different color than what you saw with the interphase. The third event that we see occurring during prophase is the nuclear envelope goes away. And now these chromosomes are freely floating in the center of the cell, which is what we see here on model number 3. There's no more nuclear envelope, which if you look at number 2, there's still a nuclear envelope. But as prophase gets into its end, the nuclear envelope will dissolve, and the chromosomes will now be freely floating within the center of the cell. And those are the 3 key events of prophase. Now, under the microscope, the first thing that we should note is that the nucleus has no longer got that nice little purple color. Now what we're seeing is a black color. So if what you see is the same cell we saw in interphase, kind of looks like an egg that's frying on a skillet, right? Yolk, white. Well, now the yolk turns black. So if you see a black yolk and it's a nice circle in the center, you got prophase. Because all the other phases you're going to see, they look a lot different. So if that yolk, that center of the egg turns black, but it still has that nice little concentric circle, you're dealing with prophase under the microscope. Any questions on this one? The next phase is metaphase. Metaphase is the easiest of the phases to see. It tends to be the one they ask, right? They ask it, I think, more often than the other phases. Metaphase, what's happening here is the chromosomes are now lining up down the center of the cell. The chromosomes are lining up right down the center of the cell. The chromosomes are lining up right down the center of the cell. All right? This phase happens very, very quickly. All right? What's happening is the centrioles with those mitotic spindle fibers are pushing the chromosomes to the center of the cell. And so we get what looks like a lizard or a snake or a cat's eye appearance. When you see this under the microscope, Ray Charles can see this under the microscope. Right? So he was blind, by the way.
Oh.
Sorry, my references are old. I am literally twice y'all's age. All right? I'm old enough to be most of y'all's father. So Ray Charles was a blind singer, played the piano. So I say Ray Charles can see it a lot. So just means blind people can see it. You should be able to see it. Everybody cool with metaphase? Which brings us to the third phase. This is anaphase. And what we talked about in anaphase are one key event is taking place. And that is that the centrioles are now going to start to shorten their mitotic spindle fibers, literally tearing apart the chromosomes and bringing half of the chromosomes to one end and half of the chromosomes to the other end. The chromosomes are splitting, half of them are coming to one end, half of them are moving to the other. And the chromosomes will continue to move further and further to the opposite side of the cell until the very last thing that we will see in anaphase is the creation of a cleavage furrow. We'll see the creation of the cleavage furrow. Everybody with me? Now, under the microscope, if they ask anaphase under the microscope, it will always, I promise you, look like this. You will not see a cleavage furrow. You will see a round cell with 2 sets of chromosomes that are nicely lined up, kind of creating an equal sign. If we inverted this, it looks like an equal sign. They will not, I won't let them pick a picture that looks like this. All right, I will make sure that there is some space between the chromosomes. That's a promise. Everybody good with anaphase? Which leaves us with the last phase, which is telophase. In telophase, throughout the whole portion of telophase, we have a cleavage furrow. The big thing with telophase is that we see the and statement of a nuclear envelope. When you looked at anaphase before it, no nuclear envelope. Telophase, a definitive nuclear envelope. So as you're looking at this one, and you're comparing this model to this model, this is anaphase, no nuclear envelope, right? Telophase, you can see the nuclear envelope, can you not? That's the key difference between the two from the model standpoint. Now, under the microscope, it'll look like so. If you see a cleavage furrow under the microscope, it is telophase. Period, end of story. I know I just told you that the cleavage furrow begins during anaphase, and technically that's true, but it's the exact last thing that the cell does in anaphase. From that split second on, the cell is in telophase. Does that make sense? So if you actually catch a cleavage furrow like we see here, or the cleavage furrow like we see here, this cell is in telophase. Period, end of story.
So anytime they're about to separate but still combine, they're telophase.
Amen. If you see a cleavage furrow under the microscope, that's a cell where the nuclear material has gone to the opposite side, the nuclear envelope is redeveloping, and the next thing that this cell is gonna do is literally split into two new cells, right? Which is technically what you see in this model here. Model number 8 will never be on your lab exam, so do not worry about this model. They use this model for the concept of cytokinesis. In my opinion, that's garbage, because what you're seeing here are two new cells. So I always make sure that this will never be on your test. Do not worry about model number 8. Now, what we want to do is start looking for these 4 phases under the microscope. So go and get yourself a microscope. I'm going to give you some slides, and we can start looking